Hello students. In today's video I'm going to discuss a very important concept of the chapter SHM, that is what is the energy analysis. Okay, so energy of SHM generally we call it. Okay, so let's try to understand this. Okay, so if I say guys, see, the thing is, let me put a little bit this thinner case. Okay, now I think it looks good. So guys, if a particle is performing SHM, okay, if a particle is performing SHM, performing SHM, we know that we know that we know that F should be equal to what guys? Minus kx. Of course, if if x not equal to what guys? 0. If the mean position is what guys? Origin only, then we can say that f is equal to minus kx. Why I am using like this way guys? Then because the calculation will become much easier, and everything discussing like graph and all would be much easier for me and to understand to you also. Okay, and later we may infuse this x naught also into the equation, but for now guys I am taking x naught equal to what? 0 only. So let's say guys f will be equal to what? Minus kx. So suppose guys, if the particle moves, if the particle moves from from mean position x equal to 0 to x, then work done by work done by work done by the force, by the restoring force, better to be, by the restoring force would be, because there is no other forces acting guys, this is the net force that is acting on the system. So what I can write guys, the W is equal to the work done is equal to what guys? F dx. Okay, 0 to x. So we can integrate this. Yes, it will be what? Minus kx dx, 0 to x. So if I integrate this guys, I'll get what? Minus half kx square. I hope this is okay. Now we know that guys, this force is going to be what? A conservative force. Okay, so as we know that guys, if a force is a conservative, then the work done, okay, the work done by the force, okay, by the conservative force is equal to what? Negative of change in potential energy. This we know. Okay, in the work for energy chapter you have read this thing. So guys, what we can say? We can say that ux, okay, ux minus u0 means at mean position whatever the potential energy you are having is equal to what? Minus w, and that is equal to what? That is equal to minus of minus half k x square. So guys, what we will get? We will get ux minus u naught, or u mean, is equal to what? Half k x square. Is this okay? So what we can say? We can say guys, ux is equal to what? Ux is equal to half k x square plus u naught. Okay, so that is the general equation. Now guys, in general, for the we know that the potential energy is always defined relative to some position. Okay, it is never defined absolutely. Okay, so if you want to define the potential energy guys for a general position, what we are going to do? We are going to define that potential energy for the origin is what? 0. Okay, if we define like this way, then we can define the potential energy for a particular position. So guys, if the if at mean position, okay, if at mean position, if at mean position we take we take we take u0 is equal to what? 0, then in that case, then in that case that case ux will be equal to simply what guys? Half k x square. This is okay. Now I'll write some important relation now that you have to keep in mind. Okay, you can derive it, just you should keep in mind, guys. So ux will be what, guys? If I write half k x, I can replace, guys, with the what, the position equation, that is what, a sine omega t plus phi whole square. So guys, what I can say, I can say that it will be what, it will be simply how much, half half k a square sine square omega t plus phi. Is this okay? I hope this is, you can understand, guys. Okay, if I take x is equal to, of course, let me write here only in the corner, assuming that x is equal to what, guys, a sine omega t plus phi. Okay, so if I assume this thing, then we can write ux is equal to what, guys, half ka square sine square omega t plus phi. So guys, if x is what, if x is a sine omega t plus phi, we also know, guys, the v is going to be what, it is going to be a omega cos square omega t plus phi. Is this or not? So if we take this idea, what I can say, I can say that the kinetic energy at the position x will be what, guys, simply half m v square, and that will be what, that will be half m a omega, sorry guys, I think here I have done some very silly mistake, that is what, this will be cos only. Okay, this will be what, guys, cos only. So a omega cos omega t plus phi whole square. Okay, 1 minute, in this small errors are happening, guys. This will be what, square. Okay, so if I write, guys, now, so kinetic energy at position x will be what, half m a square omega square cos square omega t plus phi. Is this okay? Now if you see, guys, k is what, k is, if I write the, guys, total energy, so total energy is what, kinetic energy at position x plus potential energy at position x, and that will be what, guys, that will be half m, sorry guys, half k a square sine square omega t plus phi plus half m a square omega square cos square omega t plus phi. Okay, now if you see, guys, we know that k is nothing but what, sorry, omega is nothing but what, guys, omega is under root of what, k by m. This we know, guys, omega is what, under root k by m. For a general situation, for a, if someone is performing SHM, guys, so this is going to be the case. So from there, what I can say, I can say that omega square is equal to what, k by m. So k I can replace with the what, guys, m omega square. Okay, I can replace with what, m omega square. So if I replace this, guys, what I get total energy at x is equal to half m omega square a square sine square omega t plus phi plus half m omega square a square cos square omega t plus phi. So guys, if you see, if I sum both of them, I get m omega square a square, because sine theta plus sine square theta plus cos square theta is equal to what, guys, 1. So if you see, this is coming, guys, what, constant. If you see, guys, omega for an SHM is a what, constant. The mass of the particle would be what, constant, and the amplitude of the particle is also what, constant. So it means, guys, the total energy of the system is what, constant. So what does it mean? It means that there is only the mechanical energy of the system is what, constant, and guys, there is only conversion of energies are taking place at every moment. It means potential energy is getting converted into kinetic energy, or kinetic energy is getting converted into what, potential energy. That would be happening at different moment, but the total energy of the system is going to be what, constant. I hope this idea would be clear to you. Now if we go further, guys, okay, if I write the now potential energy and kinetic energy in these terms. Okay, so what I can say, guys, that the potential energy, okay, the potential energy, guys, we know that is how much, that is half k x square. We had discussed this. Okay, so guys, from here also we can see that this m omega square is equal to what, k only, so this will be written as what, half k a square. Okay, where guys a is the what, the amplitude, and k is what, the uh, constant that was there in the force equation, F is equal to minus k. So okay, that is the k. Don't confuse yourself with the spring constant. It can be spring constant in the case of spring block system, but not always. Okay, so it is not the spring constant, guys. Sometime I have seen that student confuses this thing directly with the what, spring constant. It is only true when the system is a what, spring block system, that we can use k as a what, k will come as a what, guys, spring constant only. Okay, so potential energy is equal to what, guys, half kx square, and the kinetic energy will be what, guys, it will be, simply we can say, half ka square minus half k x square, means is half k a square minus x square. Okay, I hope this is also okay, guys, for you. So if I see, guys, this is a one important formula that also we can keep in our mind. Okay, we can keep in our mind. So now, guys, if I make a graph, of, guys, what, the energy, potential energy and kinetic energy with the what, with the position, then how it would look like, that we can see, guys. So here if you see, this is what, 0 comma 0. Okay, and let's say this is what, guys, this is our plus a, and this is what, guys, our minus a. And guys, if you see, the energy is only going to be what, positive. The total energy, guys, that could be there, the total energy is equal to what, it is going to be half k a square. Okay, it is going to be what, half k a square. This graph can show you potential energy and, guys, kinetic energy. Let's say for kinetic energy, guys, okay, for kinetic energy I am taking yellow. Okay, and for guys, for potential energy I'm taking this sky blue. Okay, sky blue. So guys, what I can show you, potential energy equation, guys, if you see, that is what, half kx square, which is a parabolic equation. So at x equal to 0, guys, potential energy will be what, 0, because the system will be at what, mean position. If you take a spring block system, guys, the spring will be what, it's at natural length. Okay, or we can call that position as a what, we have called that position as a what, guys, the potential energy is a 0. We have chosen this thing. Okay, so we can call that at this point potential energy is what, 0. And then, guys, from there if you go at a, it will be what, at maximum. Okay, and if you go at a minus a, guys, then also it will be what, maximum. So what I can say, the curve will look like what, the curve will look like something like this. Okay, something like this, guys, it is going to look like. Okay, so what we can do is, let me do little bit here. I think, okay, I hope you getting my point, guys. Okay, amplitude here you can shift. Okay, amplitude here you can shift. So this the way, guys, it is going to look like. It means, guys, when x is equal to what, 0, then the kinetic energy will be what, maximum. It means what, at the mean position the kinetic energy is maximum, and at the extreme position, guys, if you see, x will be what, a, so kinetic energy will be what, 0. So at extreme position velocity will be 0, and so we can say the kinetic energy is also what, 0. So if I make the curve for this, guys, it will look like, sorry, it will look like, okay, I hope you can see, guys. Okay, I'll just make this thing. So this would be the graph, guys, for what, the kinetic energy, and this will be what, guys, for potential energy. Okay, so this is, guys, what, this is the energy analysis, or the idea of energy, guys. The few things that we have understood from here is what, that the system's energy, okay, is going to be what, constant, because there is no external forces would be acting on the system. There would be internal forces, that's why magnetic energy is constant, and there would be continuous energy conversion would be happening, guys, from potential to kinetic and kinetic to potential. That would be going on. Okay guys, so I hope you understood this idea. In the next lecture we can take few examples on this idea. Okay, so we'll see, guys, few problems in the next lecture on this. Okay.